Let's talk about trigonometry and the unit circle. So first of all, let's talk about trigonometry. Trigonometry is the basic right angle trig. Right angle trig means that you're dealing with the sine, cosine, tangent, cosecant, secant, cotangent of an angle. Okay? So the basic angles, the most basic triangles that you need to deal with are the 30, 60, 90, 45, 45, 90 triangles. Those are the basic ones. These are your special right triangles. If you remember learning this, you probably did this before. If this is 30 degrees, and let's say this is 1 right here, that's the hypotenuse, right? Then what's this distance right here? What's that distance have to be? If you can't remember, if you put another 30, 60, 90 triangle right here, you'll see what that distance has to be. If this is 1, so is this, and so is this, because we have a 60, 60, 60 triangle, right? That makes sense? So if this side is 1, then this whole side has to be 1, which means, how much is this right here?
2.
This one right here.
Oh, 1.
If this whole thing is 1 here, from this to this is 1, then what's from here to here? It's only a half. Does that make sense? So if this is 1, this is a half, and then this, if we did Pythagorean theorem, we would see that that has to be the square root of 3 times 1/2. Just trust me on that. So it's the square root of 3 over 2. Okay, so that's our 30, 60, 90 triangle. So now if I ask you this question, what's the sine of 30 degrees? What's the sine equal to? You remember your SOHCAHTOA? Whoops. So with an H, CAHTOA. Remember SOHCAHTOA? The sine is the opposite over the hypotenuse. So what's the sine of 30? It's the opposite, which is 1/2, divided by the hypotenuse, which is 1. And dividing by 1 is just like doing nothing, right? So it's just 1/2. Right? And what's the cosine of 30 degrees?
So cosine would be the root 3 over 2.
Cosine is adjacent over hypotenuse. So it's the adjacent, which is root 3 over 2, the adjacent, which is that one, divided by 1 again, which just means it's the adjacent. In other words, if we use 1 as our radius, then all we really have to worry about is what the opposite is. Your sine is your opposite, and your cosine is your adjacent, right? That's exactly what the unit circle is. It's a unit circle because the radius equals 1 unit. So this distance right here is 1. See how it's 1 comma 0?
Yeah.
This distance here is 1. And what's this angle right here?
30.
It's 30. Why? Because this is my right triangle. Right? And what's this point right here? This point is going to be the x value, which is root 3 over 2, like we just talked about. That's your x value, and your y value is 1/2. So your opposite is 1/2. Your adjacent is root 3 over 2. And so what is the cosine of 30 degrees? It's just whatever the x value is right there, because it's the adjacent side on your right triangle.
Oh, is that how it works for all of them?
Yep, that's how it works for all of them. So let's look at the 45, 45, 90 triangle. If I drop this one right straight down, here's my 45, 45, 90 triangle. And what's the hypotenuse on that triangle?
1.
It's always going to be 1 because it's a unit circle. The hypotenuse is always going to be 1.
Okay.
And then if you remember what it is, it's 1 divided by the square root of 2 is how you find these sides. So this is root 2 over 2, and so is this, root 2 over 2. So your point is root 2 over 2 comma root 2 over 2, which means what's the cosine of 45? It's that. And what's the sine of 45? It's that. And you can do that for everything. Now look at this next one. This next triangle, if I draw it here, it's just the same. It's the same triangle as what? It's the same triangle, but it's flipped. Because this is 60, right? And this up here is 30. So the x and the y just get switched.
Oh, because you switch the triangle.
Because the cosine, let's talk about that. The cosine of 30 is the same as the sine of 60. And the reason that is because if you look at your triangle, right here, if this is a 30, 60, I know I didn't draw it very well, but let's say this is a 30, 60, 90 triangle. What's the cosine of 30? The cosine of 30 is adjacent over hypotenuse. And what's the sine of 60? It's the opposite. Well, what's the opposite of 60 going to be the same as? The adjacent of 30. That's the reason it's called a cosine, because it's the complement. That's what co stands for. The cosine of 30 is the same as the sine of 60. Same with cosecant. What do you think the cosecant of 30 is the same as?
Complement of the secant. The 30.
It's the same as the secant of 60. And what do you think the tangent of 40 is the same as? The cotangent of its complement, which is 50. That's what co-functions are. They're complementary functions, because if you look at the triangle that they're coming from, they're all what? What are the triangles always? What did I say this is called? This is called right. I didn't write it, but it's right triangle. This is called right triangle trig. They're always right triangles that we're dealing with. Okay? So look at how I put them. Well, actually, I didn't put them over. These are reciprocals of each other. These are reciprocal functions, right? These are co-functions, meaning that the sine, if the sine of theta equals 1/2, then the cosecant of theta is the reciprocal. It's 2/1. So there's all these relationships between functions. Okay, so what am I getting at? Right triangle trigonometry, the most beautiful, useful tool in my mind for it is the unit circle. And you'd think, well, what does a circle have to do with trigonometry? Well, all the circle does for us is it gives us a radius of 1, and that radius of 1 is so good because that's our hypotenuse, right? And if our hypotenuse is 1, then when we're doing SOHCAHTOA, the hypotenuse is always 1, then it's very easy to see your cosine and your sine. Okay? So let me talk about, now that I said that, let me talk about another great thing about the unit circle, and a lot of things that people have a hard time with, and that is counting radians or finding radians. They would rather deal with degrees than radians, but actually radians are a lot better than degrees when it comes to trigonometry. The more you use it, the more you realize that radians are really the preferred way to deal with it if you had to deal with lots. So here's the deal with radians. Notice that pi radians is 180 degrees. All right? Everyone knows that, right? Pi equals 180. So if I want to find out what these radians are, what's 30 degrees the same as? It's 1 pi divided by 6. Because if I divided this into 6 equal, if I divided pi into 6 equal segments, I would get 1 pi as my smallest unit. 1 pi over 6, I should say. 1 pi over 6. Does that make sense? So now we're going to count by that. This is 1 pi over 6. Skip the fourth, right? Because that's not by 30. This is 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6. This is 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. 12 pi over 6 would be here, which is the same as 2 pi, right? So this would be 13 pi over 6, 14 pi over 6, 15 pi, 16 pi, 17. It's really easy to count by 6. Likewise, it's easy to count by fourths. If this is 1/4, see, look how I'm breaking this up now. I'm breaking it up into fourths. See how it broke one full pi up into 4 equal segments? 1, 2, 3, 4. See that? 1, 2. Whoops, I did that. I did that wrong. My bad. Sorry, I made it 5 segments and they weren't equal. 1, 2, 3, 4. Make sense? Here's 1 pi over 4. Here's 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. 9 pi over 4. 10 pi over 4. 11 pi over 12. 13, 14, 15. You keep going around in circles. So if someone said to you, what's 15 pi over 4? Now there's an easier way to do it, but if you wanted to do it just the brainless way, just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pi over 4.
And you're
Wish I would have
doing
known that today.
and you're doing it like because the 4 is the denominator. That's why you've got it broken.
Yep,
into
I'm
4
doing
and
it by
6.
fourths. I'm doing it by fourths because if you think about breaking up, 1 pi, here's your 1 pi. If you break it up into fourths, it's going to be, you're going to break it in half first, right, which would be that, and then break those in half again. Does that make sense?
Yeah.
So there's 1/4, 2/4, 3/4, 4/4. You're skipping the 30s and 60s because they're not part of the fourths,
Yeah.
right? And you can do that with halves as well if you wanted to. There's 1 half, there's 2 halves, there's 3 halves, there's 4 halves, there's 5 halves, there's 6, 7. But that you don't have to worry about that. But counting in radians is actually pretty easy. And then, so if I said, what's negative 3 pi over 4? To start here at your initial side, this is always your initial side, and go 3 1/4 pi. So here's -1, -2, -3. Here's -3 pi over 4.
So like for these problems then, when it's negative.
Yeah, so let's look at another problem. If you have the tangent of -11 pi over 6, for example, if you want to find the tangent of that, if you want the tangent of -11 pi over 6, start at the initial side always. Negative is going down, you're counting 11 pi over 6's. Now an easier way to do that is to recognize that if you had -12, where would -12 pi over 6 put you? What's 12
2,
over
right?
6? Yeah, it'd be at -2, which is right back here, right? This is -2 or +2, right? You follow what I'm saying? So you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or you could have just said to yourself, oh wait, it's just 1 away from a full -12, and a full -12 would have been right here.
Oh.
So where's -11? It's right here. So this is -11 pi over 6. Got it?
So
And so what's the tangent of that? Well, we have what do we have right here? Do we have tangent? Are either one of these the tangent?
opposite and adjacent.
Yeah, all we have is the cosine and the sine. But what do we know about tangent? What does tangent equal?
The opposite.
It equals it equals the sine over the cosine.
Oh.
That's another property. Tangent equals the sine over the cosine. And so what's the sine of -11 pi over 6? Which one is the sine? 1/2. And which one's the cosine? The x value is the cosine. I'm looking at my -11 pi over 6.
Yeah, so the √3 over
√3 over 2. And how do you divide by a fraction? What do I do to divide by a fraction? You remember multiply by the reciprocal?
Oh, yeah.
So I flip this up and I do that.
Oh.
And then the 2's cancel. So it just equals 1 over √3,
Oh.
which is the same as your teacher might want you to write it as √3 over 3. And there's your tangent.
Why is it equal to √3 over 3?
Because 1, you understand how I got 1 over root 3?
Yeah.
So then your teacher will want you to rationalize the denominator. So you multiply by root 3 over root 3.
Oh, gotcha.
And you get root 3 over 3.
Okay.
They just want you to write like that. So when I write my unit circle, a lot of times what I do, in fact, you probably saw it when I first got to this unit circle page, what I'll do is not only will I write my cosine and my sine, because those are my points, but then right next to it, I'll write my tangent. Whoops, root 3 over 3. What's my tangent here? If they're the same, what's the tangent? Sine divided by cosine would be what in this case? Don't make it hard.
They just
What's
cancel
anything?
out?
Yep, and you get what? 1. What's this one? Notice it's the reciprocal of this one. Remember how this one was 1 over root 3?
Yeah.
So what's the tangent of this going to be?
Just root 3.
Exactly. What's 1 divided by 0?
0.
Nope, it's undefined. That's a tricky one. It doesn't exist. And what's 0 divided by 1? Sine divided by cosine. What's 0 divided by 1?
Undefined.
That's 0. How many times does 1 go into 0? 0 times. But how many times does 0 go into 1? Can you put 0 into a number?
Oh.
You can't do that. So that's undefined. It doesn't exist. So when you look at graphs of tangent functions, there's going to be a vertical asymptote at pi over 3 because it doesn't exist there. When you look at it on a graph of, well, it's not going to look like that. It's going to look like
We
this.
start graphing tomorrow.
Yeah. So that's an important thing to understand as well. In fact, since I've already come this far, let's talk about graphing. So let's look at these values and let's talk about how you graph these functions. So let me clear this slide. So now let's talk about how you graph tangent functions. Or let's start with sine and cosine functions. So first of all, what you're going to do is your teacher's going to have you're going to have your xy plane, and the most important point on your vertical line, the most important one is going to be, I'm going to put it up here, it's going to be this point, which is, we're going to call it 1. We're going to make these units of 1/2, intervals of 1/2, just to give us more room. And this would be -1 down here. Okay? Why is that so important? Well, what do you notice about all of the sine? Let's look just at the sine values here. Whoops, didn't mean to do that. Let's look at only the sine values. What do you notice about them? So you'll notice that they're cyclical, right? Let's just look at the sines. It goes from 1/2 to root 2 over 2 to root 3 over 2 to 1, then back to root 3 over 2, then root 2 over 2, then to 1/2, then to 0, which is where it started. Then it goes to -1/2. Then it goes to negative root 2 over 2. Then it goes to negative root 3 over 2. Then it goes to -1. Then it goes to negative root 3 over 2, negative root 2 over 2, positive 1/2, and then back to 0. And then it repeats itself. It keeps periodically repeating. What does it never get higher than? What value does it never get higher than?
1.
And why is that? Because the sine of an angle is what? The opposite over hypotenuse. And which of these always has to be bigger than the other or equal to?
The hypotenuse.
Yeah, because it's a right triangle, right?
Oh, and
A
because that's
hypotenuse
1.
always has to be bigger or equal to, so it's never, the sine is never going to be bigger than 1. Same with the cosine. So that's why I'm putting it at +1 up here and -1 down here. It's never going to get lower than -1. It's never going to get higher than +1. And so what we do is we break this into intervals. This is 2 pi. This is 1 pi. This is half of pi. And this is 3/4 or 3/2 pi. You follow? So this is my...
Wait, why did you do... Oh, because this is like where 1 would be? Okay.
Actually, let me spread this out a little bit more. Let me give us a little bit more space so we can see it a little bit better. Let me go... let me go like this. Let me call this 2 pi right here.
Okay.
So this is pi. So this is pi over 2, and this is 3 pi over 2. And this is pi over 4. That's my 45 degree, right?
Yeah.
This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. 6 pi over 4, 7 pi over 4. Remember how we talked about counting? Counting with fractions? Counting in fourths?
Oh,
I just
yeah.
counted in fourths, but now I'm counting instead of around the unit circle, I'm counting on a grid. So this is negative pi over 4. This is negative 2 pi over 4, which is pi over 2. This is negative 3 pi over 4.
Yeah.
This is negative 4 pi over 4, which is the same as negative pi, etc. Okay, and what other values we want? Well, here's 1/2. Here's negative 1/2. Let me get red now, and we're going to graph the sine. Y equals sine of theta. So let's look at first of all, our basic ones. What do we notice about the sine of 0? What's the sine of 0? It's the y value. It's 0, right? So the sine of 0 is 0, so I'm going to start here. What's the sine of pi over 2? Look at pi over 2. What's the sine?
1.
It's 1. So at pi over 2, it goes up to 1. What's the sine of pi?
0.
It goes back to 0.
Oh.
And what's the sine of 3 pi over 2?
Negative.
It's negative 1. So right here, it's negative 1. You see what I'm doing?
Yeah.
And then it gets back to 0 at 2 pi, right?
Mm-hmm.
So do you see what's happening? Well, let's do some more. We have this one, don't we? What's 30 degrees?
The sine?
The sine of 30 is what?
1 over 2.
It's 1/2. So 30 degrees would be like right about here, right?
Yeah.
And then what's the sine of pi over 4? It's root 2 over 2, which is a little bit more than 1/2. Root 2 over 2 is a little more than 1/2. If you punch in your calculator, you'd see that. And what's root 3 over 2? Is it bigger or smaller than root 2 over 2?
Root 3 over 2 is bigger.
It's a little bigger. And then what's 3 pi over 4? What's the sine of 3 pi over 4? It's back to root 2 over 2. It's back to that same point. This same point right here. See that point? That's root 2 over 2. It's the same. You follow what I'm doing?
Yeah.
And what's the one right before that? That's going to be that's going to be this one right here. That's going to be root 3 over 2. Do you see what's happening? It's this same point. It's that same height right here.
Yeah.
You follow what I'm doing?
I think so.
And then this is going to be right here. And then what's going to happen when it gets down here? Trust me, it's just going to go negative.
Oh, and that makes sense too because they're all like the same numbers. Just
Exactly, they're the same numbers. Whoops.
Oh.
Okay,
Yeah,
so that's what we're doing when we're graphing this. It's a smooth curve like that. And then it keeps going. It keeps doing that same thing. That's going to be here. That's going to be here. It's going to just keep going.
Yeah. Oh.
It's going to keep going.
So this is what we're learning tomorrow.
Whoops, I did this in the wrong place. This point should be here. This point isn't here. This point is right here. Got it? And it keeps going like that around there too. So this is one, it's called, this right here is called 1 period.
Oh yeah.
This is called 1 period of my unit circle. The yellow shaded part is called 1 period. And it's called a period because it does the same thing. It repeats itself immediately after that.
Like a cycle?
It's a cycle. That's exactly, it's 1 cycle or 1 period. Okay, so what I'm trying to help you understand is that this sine graph, your unit circle is really, it's one way to look at sine, cosine, tangent, cotangent, all that kind of stuff. Another way is to put it on a graph like this. and look at the values.
Yeah.
So notice what this is right here. This, between these two things, that's my first quadrant. That's this first quadrant.
Oh.
All those values, see how it goes from
Yeah, so it's
0
kinda like-
to 1? You're flattening it out. You're exactly what you're doing. From here to here is your second quadrant.
Oh, that's cool.
Is the sign positive or negative in the second quadrant? Just look at this picture. That red thing is the sign.
Negative. Because it's going downwards?
Nope, it's positive because it's above the x-axis.
Oh.
These are, right? Negative would be down below here.
So it doesn't matter what direction
This
it's
would be
going?
negative, right?
Yeah.
And it's not down there, it's above there. Doesn't matter which direction it's going. That's actually calculus. When you say that question, that's called the derivative. That's called the derivative, which is a calculus thing. So it's good that you're thinking like that. But no, I'm not talking about increasing and decreasing. And what's this going to be right here?
So those are negative.
And what quadrant is that?
The third one?
That's right. And look at my third quadrant down here. What are my sign values in that quadrant?
They're all negative.
They're all negative. And what are my sign values in the fourth quadrant?
Negative.
They're also negative. Now, what happens right here? What would this quadrant be? What would this quadrant right here be to the right of it?
Positive?
It is, but what quadrant? 1, 2, 3, or 4?
Isn't it back to 1?
It's back to 1 again. Exactly. And what would this quadrant be right here to the left?
2?
Does it look like 2?
No. 4?
It's 4. Very good. It's the fourth quadrant. This is the fourth quadrant. You understand?
Yeah, it's cool.
Okay, now let's do another one. I'll do it quicker this time. Now let's do the y equals the cosine of theta. What's the cosine of theta going to look like? Let's just do it quick. I'm going to do it quicker. What's the cosine again?
The x
It's the x values. Do you see what the x values? Where do they start?
from... Oh, they go from bigger to smaller.
It goes from bigger. So it starts here, and it goes here, and then it goes here, and then it goes
Oh,
here,
so it's just like the...
and then it goes here. So it's a shift. It's really a shift by, guess how many degrees? Since it's a cosine, how many degrees are you shifting your sine function? What does co mean again?
It's like the same. It's like equal.
Complementary, 90 degrees. You shifted it 90 degrees. You're shifting this graph. Look, if I shifted this graph over 90 degrees to the right, what would I get back to? What would I look just like?
Your
The sine one. So the sine and the cosine graph really are the same graph. They're just shifted from each other.
Yeah.
Does that make sense? And then I'm not going to bother with the tangent graph yet, but the tangent graph is also, you're going to have some, the tangent graph is going to have some asymptotes. I lied. I am going to start with the tangent graph. Let me just real quickly explain the tangent graph to you. So y equals tangent. Remember what the tangent equals? It equals the sine over the cosine. So whenever the cosine equals 0, are you allowed to divide by 0? Is that legal to divide by 0 in math? Can you put 0 into a number? No. So you're going to have an asymptote wherever the cosine equals 0. So here's my cosine equals 0. That's going to be an asymptote.
Oh, is it
Here's
just
another
any
one.
time that
That's
it's on
going to
the
be
x-axis?
anytime the cosine equals 0, which is the blue graph. That's going to be an asymptote for your tangent graph. So your tangent graph has asymptotes at pi over 2, 3 pi over 2, and anything else related to it. And then wherever the sine equals 0, what's the 0 divided by 1? Remember, sine 0 divided by 1. So what would my tangent be for 0 degrees? 0, tangent of 0 equals 0 over 1, which equals 0. So the tangent equals 0 wherever the sine equals 0.
So you get an asymptote whenever it's cosine of 0, but you get your...
For the tangent graph, yep, wherever the cosine is equal to 0, because remember the tangent equals the sine over the cosine.
Yeah.
So wherever cosine equals 0, the tangent isn't defined there because you can't divide by 0. 1 divided by 0, 1 divided by 0, it does not exist. You can't do that in math. How many ways can I split 0 pieces of candy with 5 kids? There are 0 pieces of candy, right? How many ways can I split 5 pieces of candy to 0 kids? How many ways can I give 5 pieces of candy to 0 kids? I can do that 0 ways because I just keep all the candy. I don't give it to the kids. That's maybe one way to think of it. Anyway, so let's do one more thing. Let's find out when the sine and the cosine are equal to each other, which is this point right here.
Which point?
At this point, at pi over 4, the sine and the cosine are equal to each other.
Yeah.
Right? Remember we talked about that? What's the tangent of this? What's the tangent of 45?
It cancels out.
Cancels to what?
1.
1, exactly. It doesn't cancel out to nothing. It cancels to 1, right? So that would be 1. So at this point, you would be at 1.
1.
At
like
1.
Along the
Yep.
y.
Mm-hmm. The y value is 1. The tangent of pi over 4 is 1. So that's my point. And what's the tangent of negative pi over 4? The tangent of negative pi over 4, which is right here. Remember how this is negative pi over 4 because you're going in the negative direction? You're in the 4th quadrant?
Yeah.
So what's the tangent of negative pi over 4? What's negative root 2 over 2 divided by positive root 2 over 2?
Negative 1.
Very good. It's negative 1, so it's this point right here. And what happens is this. Your tangent function looks like this. It looks kind of like a cubic function. It's not because there's asymptotes, but it kind of looks like a cubic function. And there's your tangent graph. And it makes sense too because look at what your cosine is up here. What's your cosine in this region up here? Is your cosine positive or negative in that 4th quadrant between negative root 2 over 2? Or?
Positive.
It's positive. And what's your sine? The red one. What's the sine graph?
Right there.
Yeah. It's negative, right?
Yeah.
So what's a positive divided by a negative?
A negative.
It's going to be a negative, and that's why we have this. That's why we have this graph negative right here. Because it's a positive divided by a negative. And what are the sine and cosine in the 1st quadrant right here? They're both what?
Positive.
They're both positive. What's a positive divided by a positive?
Positive.
A positive, and that's why it goes up like that.
Oh.
So that's just a little graphical analysis and a little instruction of trigonometry from the very basic to the unit circle to the graphing, kind of as a big old overview, and hopefully that makes sense.